Okay, so example 1, we have 8v cubed minus 82 v cubed, or v squared, plus 24v minus 47, and divided by v, oops, not plus 10, v minus 10. Okay, so the way you set up synthetic division is you start with your divisor, okay? You're gonna draw this little box right here. And inside that box, you take the root that comes from the divisor and you switch the sign. So if it's negative 10, you put positive 10. So right here goes the root of your divisor. And I'm gonna just make a note here to switch the sign. Okay, then the next thing we're gonna write out is all the coefficients. Now, if you guys remember from yesterday, when you guys were working on these, sometimes some of the coefficients, I'll bring it back, were missing. Like he started with like the exponent of 4, then 3, then all of a sudden there was a missing squared term. Okay, we have to count for that here too. So we got to just double check. Are all the terms there? Well, if we start with q, we should expect squared, then v, and then just a constant. So we're good. All right, so you always want to check for missing terms first. Next thing you're going to do is write down all the coefficients. So remember, the coefficients are just the number in the front. So what's the first coefficient? Okay, 8, then what? Minus 82, then 24, then negative 47. Okay, now what I want to do is I want to make a line underneath the numbers, but leave some space under those under these numbers, because you're going to write in some values right underneath. Okay. So here I'm just going to make a note of that these are the coefficients. Okay, now the first step is I bring down the first coefficient. I just bring it down. Okay, meaning that I just bring it down here. Okay, now you're going to be doing two things. You're going to multiply and add, and you're going to go in that pattern: multiply, add, multiply, add, multiply, add. The first thing I do is I go to the root and I multiply that times that first coefficient. So 10 times 8, that goes right under that next coefficient. So it kind of goes this direction. It goes down, then up. Down, then up. Now the ones that are above each other, instead of multiplying, now I add them. So negative 82 plus 80 minus 2. And then I repeat the same thing again. 10 times minus 2, minus 20. Same thing. Go down, add them. That's positive 4, or 24 minus 20. Multiply again. Remember, I'm multiplying the root every time. Okay, so I'm just multiplying. Zoom out a little bit. So multiply the root. Then add. Okay, so down 10 times 4, 40, and now I add these two together, and this is the last step. So negative 47 plus 40 is negative 7. That very last number That's the remainder, just like yesterday. Okay. So those are the steps to work things out. Now what comes next is now putting this in to your quotient form, basically writing out your answer. Now, another thing you might want to notice from yesterday is that whatever the degree was of your dividend or what was being divided, your answer was always one less. So if you started with degree of 4, your quotient was always 4, right? Or if it was 4, if it was 5, then my quotient was 4. So I always go down 1 every time when I divide. So these are the coefficients of your answer, okay? Those are the numbers that go in front. So my answer for this one, I start with 8. If I started with cubed, my first term will be what? Squared. Okay, then I just go down in order. So now 2, what will go after that? Just v, then just plus 4. This one doesn't have a variable, right? And then the last part is your remainder, and you do that the same, just like yesterday. So here I do minus 7 over the divisor. Okay, so that's the result. That's your quotient. That's what you get. Now, question is v minus 10, is it a factor of this polynomial? Yes or no? Like if I graphed this, would 10 be an x-intercept? No. How do you know when it is? Like after I've worked out all these steps, how would I know if like this tells me about the x-intercept? The 0, right, the remainder. The remainder is the key part. If you get that 0, you know that that is an x-intercept on the graph. So v minus 10, is not a factor because remainder does not, remember that means does not equal 0. Now I'm going to do one more example, but before I do that, on yesterday's homework, on the back page, it had asked you to write your answer in this form. Okay, you're doing the same math, but it asks you to write your answer in the form p of x equals d of x. D of x stands for divisor, okay, times q, which is your quotient, which just means your answer, plus the remainder. So I'm going to show you how to do that, because when you guys work on this, on the last 2 problems on the front page of today's, and this is from yesterday, you're asked to write it in this form. So instead of writing it like this, this is just a quotient, by the way. This is the quotient, or answer, whatever you want to call it. That's the quotient only. Okay, but to write it in that form, I'm just going to use, let's say, I got to come up with a letter here. I'll say P, just because it's polynomial, of V. So that's the name of the function, is equal to, we're going to say D of V. And remember, this just stands for the divisor. Times Q of V. Instead of X, we're just using V, by the way. Otherwise, we'd have used X. Plus R, which is your remainder. So quotient, which again is just your answer. and then R stands for your remainder. Okay, so let's put it in that form. So now P of V times the divisor. What is the divisor for that problem? Not just 10 itself. V minus 10 is that whole factor. V minus 10. What's the quotient? Basically what you came up with. So 8V squared minus 2V plus 4. And then what's the remainder? Minus 7. Okay, and when you put it in this form, you're already including the divisor, so you don't have to put it like over V minus 10. Okay. So basically you're rewriting the original function into this form. Okay. So whenever it asks you to do it in that form, that's what that means. Okay, when you do divisor times quotient times plus the remainder. Okay, so example 2. Let's do x cubed minus 56x plus 49. What I'm going to do is put like kind of that division symbol like that, and then put the divisor in front of it. And just remember, these problems are all the same. They're just written differently. Sometimes it's written like this. That's called a rational. Okay, this is the division symbol. Sometimes they just use the other symbol, which is like the 2 dots with the line in between. Okay, I'll leave some space over here for notes. Okay, so first, do we have any missing terms in our dividend? X squared. So we are missing some. So again, always check for missing terms. So in this case, x squared is missing. So when I write that out, I'm just going to account for that when I write out the coefficients. Okay, so first we're going to write that little box. Now the factor or the divisor is x minus 7. So what goes in the box? Right, positive 7. Remember, always switch that sign. Okay, so now the coefficients first, 1. What comes next? Well, we're missing x squared, right? So if we're missing x squared, what coefficient goes in place for that? 0. Okay, so just remember x squared is missing here. So that's what we're writing in place of that. Okay, and you could have multiples missing. You could have like 3 missing. So every time you have 1 missing, put a 0. Okay, then minus 56 and plus 49. Okay, so now I'm going to put my line down here. Leave some room. Bring down the first coefficient, which is 1. First step, multiply. 7 times 1, 7. Then add 0 plus 7, 7. Then again, multiply the root times the value or the new coefficient down here, which is 49. Then add again. That gives you negative 7. Okay. And then again, multiply 7 times negative 7 minus 49. And you can see we end up with 0. So my remainder is 0. All right, so let's answer some questions before we go on. So if the remainder is 0, what does that tell us about the divisor or the factor? What does that tell us about x minus 7? Is it a factor or not a factor? Yeah. So x minus 7 is a factor because r equals 0, or remainder equals 0. We could also say the x-intercept is, what is the x-intercept? Because that is a factor, so that means that tells us what an x-intercept is. What is it? 7 and 0. So if I looked at the graph, I would find it crossing through 7 at some point, okay? All right, so now let's write out the quotient. Okay, so first, I start with x to the what? What power? Squared. Remember, you start with one less. Always go one less than what you started with. So that was 3, I go down to 2, and then I go down from there. So now plus 7x minus 7. There is no remainder, so that's my answer. That's my quotient. Okay, now let's put it in that like kind of p of x form. All right, so now p of x equals, first the divisor, x minus 7, then the quotient, x squared plus 7x minus 7, and then lastly, we add the remainder, which there is none, so that's it, because the remainder is 0. So basically what this is, all I did was rewrite this, x cubed minus 56 plus 49 into this form. In other words, we factored it. So it's been factored. That's really all you're doing, is you're using division to factor. So using division to factor, which helps us find those roots, helps us figure out where they cross the x-axis. Where does this situation start and where does it end? Because a lot of times the x-intercepts are associated with like where something begins or where it ends. Especially if you guys take physics, and you start working with quadratics and it's raised to the square power, a lot of times you're using those x-intercepts to figure out where something started and or where it ended. Okay, so last thing I'm gonna do is just gonna go over some things in the packet. Let me just over a little bit. Okay. So first thing is just a reminder, cross that one out. Don't do that one in 8.3.1b, just because, like I was explaining in the beginning, in order to do synthetic division, that first number on your divisor has to be 1. So you can't have like a 3 or a 5 or something like that. Okay, so just cross that one out. So if the only way to do that is to do box division, okay, or Polynomial box, or sometimes they call it long division. Okay, but if you did it already, it's fine. But you know, if you didn't, you don't have to. All right. So then the rest of these you can do synthetic division, but again, look for missing terms. Remember, this is the same problems from yesterday, so you should already know which ones are missing. Like that one, you can tell there's missing terms, and same thing with that one, B and D. Okay, the ones on the bottom, you're going to do synthetic division again, except now you're going to write your answer. You're going to actually write out the full factored equation. So you're going to write it in this form like I showed you in the notes. Okay. So same steps, you're just writing out your answer differently. Okay, you don't need to write the quotient form, just write the function form or factored form. Okay. You guys get on the back side, you flip your packet. It says, Carlos is waiting to always playing games with his graphing calculator. And here's the deal. When I was in high school, we were using graphing calculators, TI-83s and all those stuff. And some places still do. And And, you know, in a normal class setting, I would probably teach you guys how to use it. But honestly, in the scenario we're in, we've been using Desmos. And Desmos is honestly being used more and more and more, especially if you're going to be going to a university. You're probably going to be seeing that a lot more in class, okay? Especially because you have Desmos on your phone. You can actually put it right on there. I use that app, by the way, if you guys want quick access to it. So instead of a graphing calculator, we're using Desmos. Okay. Yeah, it's contracted a virus, yada, yada, yada. Okay, it says use trace and zoom in the window. Trace and zoom is all it is. It's like, you know, just zooming in to be able to see what the graph, zooming in and out. Trace is just like, it was this tool on your graphing calculator to be able to like go across the graph and see what the points are. So like, for instance, if I graph, let's graph something on Desmos. Let's say x cubed minus, actually, let's look at the last one we just did. So minus 56x plus, plus 49. Okay, so if I zoom out, trace on the graphing calculator, all that did was allow you to like see these points. But Desmos is kind of automatic. It's like if you clicked and kind of dragged anywhere on the graph, lets you see all those points. That's what trace is on the graphing calculator, okay? Which, by the way, if I write this in that other form, in the factored form, so this is after factoring that same function. Let's see, plus 7x minus 7. You'll see that they match up. They are the same graph. Okay, it's just written in factored form. All right. So what you're doing is, let's say we're starting with that, right? Let me go back here. He says he needs to solve this function. When something is saying, when a question is saying you need to solve, what are we looking for? For what? X, or what on the, what is that on the graph? What is, when you say we're looking for X, what is that on the graph? Where do you find that? Like, where's the answer here? The x-intercepts. So remember, those things are all the same. If something asks you to solve, that means that we're looking for roots, x-intercepts, solutions. Okay, could be factors. Okay, these are all kind of like the same thing, just written differently, right? Next x-intercept is written as a point. So let's say my x-intercept is 2. A root would just be saying that the root is 2. Next intercept would be 2, 0. A solution would be x equals 2. And the factor, what's the factor for 2? X minus 2. So you see how they're all like the same thing? They're just like, they're expressed differently, okay? So it's all asking about the same thing. Okay, and that's the kind of the whole point of all this. So he graphs it. All right, so he puts it on a graph. He does y equals instead, which, by the way, when you do, you want to do y equals when you graph these. If I do equals 0, it doesn't let me click on the x-intercept. Like, it won't let me like trace it and see what it is. So in case you're like, why is it not letting me see it? Just don't put that. And then you'll see that it pops up. If you put y equals in front of it, it'll still let you see it, okay? Just don't put equals 0. Okay, so he sees the graph and standard window. From the graph, what number appears to be a integer solution? What kind of numbers are integers? What's an integer? Huh? Yep, it is positive and negative, but they're all whole numbers. So they're not fractions, they're not decimals. What are the whole numbers? So when you look at the graph, look for the whole numbers. And you can see over here, it actually gives you like a quick graph of that. How many of these, first of all, how many times does this graph cross? 3, 1, 2, 3. And how many of those are integers? Just one of them. What is the integer? So that's your one integer. It says verify that your answer to part A is a solution. Okay. Well, we can use Desmos for that. So we'll just kind of give you a pass on that. Use Desmos to double check. Okay, check to see it's an x-intercept. So since you know it's a solution, what's the factor? So now you're going to write that in the factor form. Okay, I'll let you guys do that. Okay, use polynomial division to determine the other factor. So if that is our factor, can we use synthetic division here? Right here, I'll just write it in. This is x what, by the way? Plus 7, because remember, opposite sign. Can you use synthetic division to check that? Or yes, why? The first number is a 1. So I'm going to set this up, and then I'm going to use these coefficients, make sure there's nothing missing. 1, 5, negative 16, negative 14. And then as you do this, first of all, what remainder are you going to end up with? We already know it's an x-intercept. We already know for sure. You should end up with 0, right? Because we already know it's an x-intercept. Okay, so as you work through that, you better get a 0. Otherwise, you did something wrong. Okay, now in the next step, you can see here, it's asking you to write it in this form, basically in the factor form. So once you get your quotient, you're going to write that over here. And obviously, leave yourself enough room to write that out. By the way, what's the power of the first number going to be? What's the power of that first coefficient going to be? X squared. How do you know? Right, because it started with Q, right? It started with 3. Okay, so the other factor leads to 2 solutions to the equation. Guys, look at the graph. Are those solutions going to be whole numbers? Those other 2? No. So we're going to probably have to use another method to figure out those other 2. Okay, if there's some funky decimal, probably quadratic formula. Okay, or maybe the box, I don't know. Okay, but you're going to need to find all 3. So basically from that quotient, from that part, you're going to find the other 2 solutions. Okay. On this one, you got to find all 3 solutions. There's 3 of them. He already gives you 1. So that means that x equals 1, I got to put that into factor form. What is it? X minus 1, and then use synthetic to division to help you figure out the rest. Okay. All right, this one right here, it's asking which of these polynomials is the standard form of that. Okay. So if you want, you guys can just use Desmos to double check and verify. So you could basically just plug these in and check to see which of these have these factors. Okay. Last one. Where's my notes from this one? Okay, this last one, consider this equation. What are the factors? Okay, what's one way we could find the factors here? Yeah, you could find Desmos. Use Desmos. Sure. Use Desmos and you'll find the x-intercepts. Fine with that. So then you'll have to figure out what are the solutions. So this kind of answers the same question, right? You're just going to be writing it in a different form. You write it here as a solution, write it here as a factor. Okay. And then the last question, how are the solutions related to the leading coefficient and the constant term? So, by the way, what's the leading coefficient for that equation? What's the LC? What number is it? What number leads the equation? 5. So basically it's just your first coefficient. What's the constant? A constant is just a number. It's -6. It's the last one, basically. It's the one that doesn't have a variable. That's your constant, because nothing changes if it's just a number. So it's just asking, how is it related to those answers? And when you see the answers, you'll see that there's something that's related to those two, okay? All right, guys online, that's it for today. I will see you guys next week. Again, don't forget to complete your guys' quizzes. Also, pick up your packets. You guys need to make sure you guys get your packets, your second and third packet, because we're starting that next week. So make sure you guys pick that up from the library. It does close at 1 today, but it will be open next week on Tuesday. And it's open from 7:30 to 4. Also, just a reminder too, if you guys are interested in that summer pre-cal class, did I tell you guys about this yesterday? Or you guys weren't here yesterday for this, right? There's a pre-cal class if you want to be able to take AP Calc next year. Obviously, a lot of people are usually interested in taking AP Calc because they're trying to put it on their transcript to apply for colleges. Obviously, that's something that obviously makes you a stronger what's the word I'm looking for? A stronger candidate. Okay, a stronger candidate for universities when you have AP Calc, especially when you're applying towards certain majors. Okay, things that have to do with math or science. It is 4 days a week, Monday through Thursday, from June 14th to the 22nd. If you do take the course, you do get college credit because it's actually taught by a Grossmont or Cuyamaca professor. It is here on campus. It's right here in one of our classrooms. The only difference between summer school and that is that it's after school. It's after school hours. So you can see that it says from 1 to 3:30. Okay, 4 days a week. So that's about, I think it's 5 to 6 weeks. So, no. Yeah, it's 6 weeks. Wait, no, that's 5 weeks. So it's 5 weeks this year. Actually, that's shorter than before. It used to be 5 days a week for 6 weeks last time. So yeah, if you guys are interested in that, one, I would recommend it if you feel pretty comfortable with math. If you really have a strong desire to get AP Calc next year. And if you've been getting good grades in math, and have a conversation with me about it, okay? And I'll put you on the list. Now, if you put your name on the list, you can always say no later, okay? So it's not a 100% commitment. It just means, hey, we want to start putting a list together, getting people applied so that, because by the 30th, you have to apply, okay? So again, if you're interested, let me know, okay? And I'll remind you guys next week. All right, you guys online, see ya.